And I can also look at what this looks like in the console just to make sure it all looks good. And down here, I still see that same thing, the 218 observations, 39 variables in this subsetted or filtered data frame. So the filter function is what helped us do that. Yes? So that happens, that's a great question. That will happen if you don't run this library tidyverse part first. And so the library, so make sure that you run basically that top part to load the library, and then run the Star Wars survey, the read_CSV to get the CSV, and then run this next part, and it should work. Did that fix it for you? No, I think that's going to be, so you have to run basically all highlight like they, yeah, and then let's see if that works. So basically the reason likely it wasn't loaded yet in your little environment. That worked? Okay. So just to recap so that everyone can sort of hear what the problem was, this code down here relies on a couple things. One, it relies on that Star Wars survey data being in your global environment. And so to get that in the global environment, you first have to run this line, which is reading in the cleaned CSV file. And the other thing this relies on is these functions, the pipe and the filter function, both come from the Tidyverse package. And so the way that R works is that there are some functions that are just built into base R, but a lot of functions are going to be in these packages that you have to sort of separately read in order to access them. And so when you see an error like function not recognized, similar to what you're seeing, almost always the problem is that you just have to load a package that will, yeah, that's a great, very good question. This is, anyone else have any questions? Okay, great. So we've got our, we've filtered to only include people between 18 to 29. I'm going to go back to our slides. I think they're here. Yes, right. And we've seen our cheat sheet as well. Okay, so I tried to sort of categorize what I think of as good visualizations based on sort of all of the different ways that you can potentially have a misleading visualization. And I came up with these rules. And so good visualizations should reveal structure, which I'll get into what I mean by that. But essentially, you don't want to mask your data with some kind of summary measure. So you want to make sure that your visualization accurately shows the structure of the data. It should show the data, which this kind of builds on reveal structure. But sometimes there's certain types of plots that are intended to be summary measures. And in those cases, it's important to also try to show the data, or at least look at the plot one time with the data to make sure there's nothing being obfuscated by the potential summary. So reveal structure, show data. It should be properly scaled. And so what that means is basically the way that you're zoomed in on either the X or Y axis should be kind of appropriate to the question at hand. And all of these, I'll give some examples of what I mean. If you're doing something with factors or categorical variables, they should be sensibly arranged. You basically want to make it as easy as possible for the consumer of your visualization to kind of draw the conclusion that you want. So when you're showing them something that has kind of a natural order, you want to order by that. There's kind of there's a plot floating around from early in the pandemic that kind of comically messed up this particular issue. So it was looking at cases of COVID in a particular county, and the x-axis was date, but date was not ordered by like calendar time. It was that bottom axis was actually ordered by like the number of people that had tested positive. So it looked like there was a certain kind of pattern, when in reality, the pattern was quite different if you looked at it over time, which is how you should actually look at it. So this issue of accidentally misordering your categories is not something that, it creeps up even in kind of somewhat professional settings, and it's something to be very cautious of when you're trying to order, both to be able to make sure you're not being misleading, but also to make sure that you're drawing attention to the thing that you care about when you're showing your visualization. And then the last point is just to draw extra attention to key points. And so I often find, not always, sometimes we're doing data visualization just as an exploratory analysis. But often if there's like a final summary figure for some kind of analysis that I'm doing, there's usually 1 or 2 key points that I'm trying to draw some kind of attention to. And it can be helpful to sort of make that very obvious, either with different colors or with some text, some labels, things like that. So we're going to talk about how to be able to actually do that as well. So we're going to be using the ggplot2 package, which is also part of the Tidyverse. So running library Tidyverse will load all of the functions you need for this. And this is the Tidyverse's data visualization package. The GG stands for Grammar of Graphics. And so basically, it was inspired by this book by Leland Wilkinson, where there's kind of this idea that all of your graphics have this kind of common grammar that you can talk about in order to kind of build up layer by layer a nice graphic from a data perspective. And I'll show you what I mean by that here. So for some of you, I think this is going to be a review if you're already familiar with ggplot2, but just to make sure we're kind of all on the same page, there are 3 main components to a ggplot2 object. There's the data, so that's going to be like what actually is behind your visualization. There's the aesthetic mapping, and so that basically means how you map that data to actual points on your graph. And then there are layers, and so you can have multiple layers. For example, you could have points and lines and colors. These are all going to kind of fall under different layers of this ggplot object. And so essentially you take your data and then you map it to some aesthetic. And so the aesthetic could be something like a point, or it could be a bar plot, or it could be a box plot. It could be a color. It could be the size. These are all different types of aesthetics that you're going to map to. So you start kind of with this blank plot and you add these geometric objects on top. And the reason I'm using this type of language, it seems sort of, they're strange words, but they map to the actual function names, which is why I'm using that type of language. So you have your kind of empty plot, you map these geometric objects on top of it. So a geometric object would be something like a point or a bar or a box plot. So you're taking that data, you're mapping them to these geometric objects. And then you can have some statistical transformations. And so that would be something like if you wanted to draw a line, so in this case, this is a transformation because it's a linear model that sort of averages across all these different points. You can also have position adjustments. And so that would be like if you wanted to jitter your points, for example. And then you can have annotations, things like labels. And so basically ggplot works by layering all these different pieces using the plus signs to indicate that you're adding another layer. And so ggplot is the main function, and the plots are essentially constructed in layers. So the structure of the code for plots is going to be basically something like this. You'll start with that ggplot function, and then you'll use a plus sign to add another layer. And you would add something like, for example, most often you're going to add a geom. So this is like a geometric object. So something like geom underscore point would add points. And I'm going to give a whole bunch of examples. So if this feels kind of abstract, hopefully it'll feel less abstract in the next couple minutes. So more precisely, this is exactly what it will look like. You'll start with that ggplot function. The first argument is going to be a data set. And the second argument is going to be your mapping. So this will be kind of how you want to map that data to your plot. And typically you're going to be mapping to the x-axis and the y-axis. And so you would map that to x equals what you want the x variable to be. Y is going to equal what you want the y variable to be. And then you can add these geometric objects or other options layered on top. So to use these functions, you first need to load the Tidyverse. And so like we noticed in that previous application exercise, if you don't load the Tidyverse, you'll get some kind of error message like it can't find the function. So you want to run this library Tidyverse part first. And there's a couple places you can get help for this, for these. So in addition to what I'm going to show today, so of course you can refer to the slides. All of the code that you would need for today should be somewhere in today's slides. But if you kind of want to take it further, there's this ggplot2.tidyverse.org will have all of the help files. And the other place you can look are the cheat sheets. And so under help, cheat sheets, data visualization, and ggplot, that should have some further information about the different functions we'll talk about. Okay, so here, this is an example of some ggplot code and the output that it would generate. So in this case, I'm mapping height versus, or mass versus height from a data set called Star Wars. This is different from the data set that you have. This is a data set that has information about particular characters in Star Wars. And so my data is equal to Star Wars. My mapping, I'm mapping height to the x-axis, which you see down here. And I'm mapping mass to the y-axis, which you see over here. And then the geometric object that I want to actually print is a point. So I want to have a point for every one of these data points. And so this is a scatter plot. And one thing to mention here, if you were to run this yourself, not all characters in this data set have height and mass information. So 28 of them are removed. So I would get this warning that says remove 28 rows containing missing values. Going forward, I'm going to suppress this warning basically to save room on the slides. But it's always important to note when you get these kind of warnings, especially because they tend to be for missing data issues, which are definitely worth paying attention to. So just to kind of give that piece. Okay, so here's that same code. At the top here, I have that exact code I had before. But what is slightly different about this plot compared to the one that I was showing previously? Yes. Exactly, the axis labels are changed. And so now instead of just being the default variable names on the x-axis and y-axis, I was able to specify what I wanted those. So I added in a specification about the units, and I also added a title. So there's this, and you can see how this worked in ggplot. So I started with my ggplot function, which I dictated my data and my x and y axis. And then I added my geometric label layer. I said I wanted to make points. And then I added another layer with this plus sign. I added labels, and I was able to update my title. So I ended up with this title up here, mass versus height of Star Wars characters. I was able to add an x-axis label, height in centimeters, and a y-axis label, weight in kilograms. And we also can notice kind of by looking at this that maybe there's an outlier in this plot, which turns out is Jabba, who is not terribly tall, but quite heavy. And so this is another, just to sort of note that when you're making these visualizations, kind of the purpose of them is to be able to draw attention to the data that you are looking at, depending on if you're doing it from an exploratory perspective, in which case you'd want to investigate this point, or if it was from a confirmatory perspective where you're trying to show a client draw attention to a particular point on your plot. Okay, so additional variables. So we can map additional variables to various features on the plot. For example, we can do something like map the color or the size or the shape or the transparency of our points or lines based on variables that we have in our data set. And we can also do something called faceting, which basically allows us to have small multiples displaying different subsets of the data simultaneously. So I'm going to show you how you would do that. Let's start with the aesthetics. So basically the aesthetic options, these are visual characteristics of plotting characters that can be mapped to specific variables in the data. So essentially color, size, shape, and alpha, these are the most common ones, where you can take a variable in your data set and you could color points based on that variable, or you could have different sized points based on that variable, different shapes of your dots based on that variable, and different alpha is basically the transparency. So for example, if you had a whole bunch of points that ended up kind of on top of each other, you might want to use an alpha to be able to make them transparent so that if there were 10 points all stacked on top, it'd be darker than if there's just one point. And so here's an example of that. In this case, I'm using the color aesthetic here to add an additional dimension to this data set. So what is my what does the color in this plot tell me? Yes, exactly. It tells the gender of the characters. And so I've got this little legend now that tells me that the red points are feminine, the blue points are masculine, and the gray points were missing that gender variable. And so this went into the AES. Again, the AES stands for aesthetic. And so that went into the AES function in the initial ggplot function, which is where I put my X and Y axis, and I can add kind of other variables that I would like to plot. You can add multiple of these. For example, here I've still colored by gender, but I have another aesthetic size. And so what does the size indicate here? Yes, someone said. Someone said it? Birth year, yeah. So the size indicates the birth year, which is another variable in my data set. So I was able to both show differences by these two different variables. So like this large dot here, I can tell is somebody, it's a Star Wars character that's masculine, that was born around year 400. And so this kind of can give me a little bit more of an indication if there's some underlying thing that's making some points look different than others. So if we thought there was some characteristic, maybe we would see some pattern in this data set. The other thing you can do is you can use these same aesthetics to map across all points. And so if you use those aesthetics in the initial AES function, like we did here, so here we had size equals birth year, it will differentiate that aesthetic based on the variable that you've specified. So here we had a different size for every birth year. But if you want to update all points on your plot, so we wanted every plot to be size 2, for example, you would put those options in the geom_point function, and that would change all of these. So now all the points are bigger than they were before. Okay, so an aesthetic summary. This sort of gives a little bit of an idea of when to use different aesthetics. So continuous measures basically are measured on a continuous scale. Discrete variables are often measured or counted on a discrete scale. And what aesthetic you'll use for each of these is going to be slightly different. So if you have a continuous variable and if you're interested in the color aesthetic, if you have a discrete variable, so like a count variable or something like categorical, it will use like a rainbow of colors to show, versus if you have a continuous variable, it would use a gradient of colors to show those differences. And similarly for like the size aesthetic, if you have a discrete variable, it will use discrete steps. And if you have a continuous variable, it'll be a linear mapping between the radius of that size, or the radius of the circle, and the value. And for the shape aesthetic, for discrete, you'll have a different shape for each category. And for continuous, it's not going to work, which makes sense, because if you have a continuous variable, you wouldn't want to have a different shape for it wouldn't quite make sense in that setting. So you use aesthetics for mapping features of a plot to a variable, and then you define the features in the geom for customization that is not matched to a variable. So there's kind of two different ways to use these aesthetics. You can either have them be mapped based on some variable, like we did when we changed size based on birth year, or color based on gender, or you can define the feature across the whole geometric object, like we did when we set the size to 2 for all of them. All right, the last part of this section is on faceting. And so faceting is basically a way to make smaller plots that display different subsets of the data. It's useful for exploring conditional relationships, and also for if you have like really large data where it's hard to sort of parse out just based on something like color. So this plot is trying to tell a similar story to my plot I showed before, where I colored the points by gender, except now instead of adding that color aesthetic, I'm going to use this facet_grid. And what I've done here is I've indicated that I would like to facet across gender. And I've also added a subtitle here to my plot to indicate that this is faceted by gender. And so if I look at it, I have a separate plot basically for each of these subcategories. So the x-axis here and the y-axis are shared, which is important because it makes it easier to compare between them. But you can kind of, it separates out each of these categories so you can better see if there are differences. And so this makes it very obvious that there's just one missing value, which is kind of worth noting and potentially excluding depending on your analysis of interest. And it also kind of gives you a sense of the distribution of these variables across this facet. If I wanted this grid to be up and down instead of side to side, does anyone have any idea how I might change this code here? Yes. Yes, exactly. So if you just flip, or maybe this is what you mean by the transpose, if you flip, if you put gender on this side of the tilde and the dot on this side of the tilde, yeah, that will make it up and down. So what this is, what a facet grid is doing is it'll create a grid of whatever variables you put into it. If you put one variable on this side and one variable on this side, it'll split it by row for the thing on the left and by column for the thing on the right. And if you put a dot, it'll just, it'll take basically across all variables. It'll look at just the thing on the right will indicate what it's splitting by across columns, and the thing on the left will be across rows. So yes, great suggestion. If we switch the gender and the dot, then we would be able to see the same thing faceted. It just would be up and down instead of side to side. Are there any questions about what we've seen so far? Okay. So as a summary, the facet grid will give you this two-dimensional grid, and it works in this rows tilde columns fashion. And you can use that dot for basically no split. So if you want to split only by one variable, you can put the dot into the other variable. There's also the possibility to do facet wrap, which will just be a one-dimensional ribbon that will wrap into 2 dimensions. So basically, if you knew that you only wanted to look across one variable, the facet wrap function is another way to do that, where you don't have to use the dot. And it'll just sort of wrap the plot based on the size. Okay. So I have this link here. If you want to learn more about ggplot2, I have a book that I had put together a while ago called ggplot2 and 2. Some of you that have taken my STA 212 or course have probably seen this, but it's essentially just, it's supposed to sort of walk you through the basics of ggplot2 in about 2 hours. This link here that has this code BEM392S22, that will make this book free. So if you are interested in it, you can do that. If you just go to this link, or if you Google ggplot2 and 2, I think it's like $15 or something. Please don't pay for my book. I'm happy to give it to you all for free. So if you add in this BEM392S22 at the end of the link, it will give you a free copy of that if that happens to be useful to you. It basically will cover kind of similar to what I've shown so far, but in a little bit more depth if we didn't kind of cover as much as you had hoped. Okay, so let's do some plotting. So I want you to copy this code into your O3 generate figures.r file in RStudio Cloud. And first, just examine what's happening in this code. So what's going to be on the x-axis, what's going to be on the y-axis. And then I want you to fill in the x and y labels here. So in this example code, I've just put dashes. I want you to fill in kind of descriptors of what you think these axes are showing. And then go ahead and run the code, and we can talk about what you see afterwards. I'll give you a couple minutes to work on that. If you need the ggplot cheat sheet, again, you can find it under Help, Cheat Sheets, Data Visualization with ggplot2. All right. Let's switch to the RStudio Cloud. This one awake? No, it went to sleep. Okay. I'm going to go ahead and add this in. What is on the x-axis? What would you expect to see on the x-axis? Yes. Yes, the rank of episode 1. And what about on the y-axis? What would we expect to see there? Yeah, how favorable admin is to the survey respondent. Great. And so when you run this code, we end up with this where we have an x-axis, a y-axis. We've got values here on the x-axis, 1 to 6, and we've got values on the y-axis from, that look like our favorability ratings, but there's nothing actually plotted here yet. And that's because we haven't added any kind of geom. So we haven't actually added a geometric object to this. We've just sort of created the outline of our plot. And when I'm doing graphics, I like to try to build up my graphics like this, where I sort of start by thinking about what's going to be on my x and y axis. And I make sure that I've got some nice labels for my axes as well. And then I kind of build up from there. Are there any questions about what we've done so far? All right. Great. So good visualizations, they reveal structure. What do I mean by this? So here is a plot where if I just used a summary measure, like the average, for example, I would see an average right here in the middle. But by looking at the actual histogram of the data, that kind of gives me an idea that this actual average is sort of a meaningless piece of information. In fact, the average is where the least amount of data sit in this particular data set because it's bimodal, or it has kind of two distinct distributions here. And so this is what I mean when I say reveal structure. A histogram, like what was plotted here, is a good way to reveal structure of continuous data, because it actually shows you the distribution of that data as opposed to an average, which just would give you a single summary measure. Here's another example. Here I have 12 different plots. And in all 12 cases, these are all kind of different data sets. And I'm trying to look at the relationship between X and Y in each case. And so this was created using a facet, like we talked about last time. And each of these lines indicates this is a linear model that was fit between X and Y. A linear model is another version of a summary measure. And I've got my confidence intervals here. And by just looking at this without kind of revealing any structure of the data, I could think that all 12 of these basically follow a similar relationship. The relationship between X and Y looks very similar between all of these different faceted plots. But if I actually plotted the data points in each of these cases, this is what these data look like. They look kind of wildly different in every case. This is a famous example that a couple folks came up with a couple years ago that builds on a previously famous example called Anascambe's quartet, where basically it shows that you can get the exact same summary measures for different data sets that have wildly different actual underlying structures. And so, for example, here, this data set looks like a dinosaur, and you wouldn't know that if you didn't plot the data. Similarly, this data set here looks like there's some kind of categorical variable that's changing the relationship between X and Y that makes the relationship actually a negative relationship. and much stronger than the one that's seen if you just look across all the data. And this one kind of looks like the opposite, where it looks like there's a strong positive relationship if you actually account for the variables, et cetera. So this is sort of demonstrates why these summary measures by themselves, without actually putting the data points behind them, can hide something important. And so good plots will always reveal the structure of the data in order to make sure that you're not kind of obfuscating something important. And so there's different types of plots that sort of solve different data problems. And so I think this is very likely going to be a strong review for many of you, but I think it's just important to sort of touch on when thinking about the type of plot you're going to use to reveal the proper structure. So there's continuous variables. These are going to be like numeric, and then there's categorical variables. These are going to be things like vectors or categories. And categorical variables can also fall into different there's different types of categorical variables. There's nominal variables. So like, for example, chicken, unicorn, and giraffe, these would be nominal. That means that essentially the categories are not ordered. There's not a natural ordering to them. There's just different categories. And the way you would handle nominal data, or the way you might sort nominal data, would typically be different than how you might handle ordered data. So here's an example of ordered data. This is a happy, neutral, and sad person. And the way you might plot ordinal data would actually take into account the natural ordering, whereas the way that you would plot nominal data might take into account something else, like maybe the frequency in your data set. And so for visualizing numeric data, the ways that we tend to describe numeric data are via like the shape, the skewness, the modality. So is it unimodal or bimodal? That plot that I showed before with the histogram was an example of a bimodal data set. So these skewness and modality are both examples of shape. And then we could have things like center. So that would be things like the mean, the median, and the mode are sort of measures of central tendency. And then you would have summaries based on the spread. So this would be things like the range, the standard deviation, or the interquartile range. And then finally, you might have some unusual observations like we saw in that example where we had Java as one of the variables or one of the data points. So the way that we can do this in ggplot, the most common thing for a continuous variable is to plot a histogram. And so this is going to be just using geom_histogram. So what's different here between what we saw previously with geom_point is we've just changed the geometric object that we're plotting. And now, because a histogram is only one dimensional in the sense that it only relies on a single variable, so you don't need to plot something to both the x and y axis. You only need to tell it what x variable to have, and it will automatically use count as the y axis. So you only need to pass a histogram one parameter or one variable from your data set. So in this case, I'm showing a histogram of height from that Star Wars data. This bin width option is saying how wide I want these bins to be. By default, ggplot will always make this 30, but it's a good idea to actually take a look at your data and see kind of what is best based on the units that you know your data are in. This is a histogram. It's always a good idea to sort of look at your data if it's continuous via histograms. Another way is a density plot. So you can do that by using geom_density. And you'll see that's very similar to the histogram. It just smooths that line across. You can have side-by-side box plots as well. And so this is going to basically be a way to look at a continuous variable, for example, still height here, by another variable, for example, in this case, gender. And so the way that this one is set up, on the y-axis, I have height, and on the x-axis, I have gender. It might be confusing that these were flipped here, but it turns out that any function in R can take arguments in any order as long as you name them. So here I've named the first, I've indicated that I want my first argument to be for the y argument, and the second to be for the x. And so I use the geom_box plot to make those side-by-side box plots. And it's a good idea when we're showing our data to always include the actual data points on each of these. And so this is where that show your data piece comes in. And the big function that's going to be used most often when you're using a box plot for showing your data is this geom_jitter. And so what that does is it's very similar to geom_point, but instead of putting it at the exact spot, it'll jitter it a little bit so that you don't have points kind of overlapping each other. What do you think this would look like if I didn't include, if I used geom_point instead of GeomJitter? Yeah. Yeah, it would be a lot more clustered and harder to read. And in fact, so it would plot it exactly on the x-axis, on the x line, according to the category. So you would just have this line of dots here at feminine, and you'd have this line of dots here at masculine, and a line of dots here at NA. So the jitter basically kind of spreads those out a little bit from right to left, and also slightly up and down, although not so much that it actually like distorts the information. And so this is really good. And we'll see in a second kind of why this is good. But when we're thinking about showing our data, this is really important because sometimes things like box plots can sort of mask the truth behind the data. One other thing I'll mention is by default, the geom box plot function will put a little dot for all of the outliers. And so when you're using the geom_jitter, it's important to add this outlier.shape equals NA. And that's because you don't want it to be kind of double plotting those outlier points. So if you don't have that, it'll leave these little points on this, and it will also, with the GeomJitter, plot that point again. So you'll want to just remove those if you're using the GeomJitter. Okay, so now for categorical data, there's a couple different ways to show that in R. The most common way to show categorical data is via a bar plot. And so maybe as is obvious now, we're just going to use geom_bar here. So here I'm mapping gender to the x-axis, and it's going to just count each of those categories and create this little bar plot. You can also have segmented bar plots. And so if I wanted to, for example, color by something, I can use the fill equals hair color. And this is going to fill in the different parts of that bar plot based on the hair color of the individual that it's referring to. And you can actually even have segmented bar plots that show things as proportions. And so to do that, I add this position equals fill option. And I'm trying to show you a couple of the different types of options you can do with ggplot, but I'm not intending for you to have to memorize any of these. All of this information is in those cheat sheets as well as the different documentation, but just to kind of give you an idea of the different types of things you can do. And so now instead of looking at a count in each of these, it's looking at the proportion in each category of each of these hair colors. And that can be helpful if you're trying to kind of compare within groups. Like for example, it looks like the masculine group has a higher probability of not having any hair color. So having this purple none category is larger than in the feminine or missing group. Okay, so we've sort of given a little bit of indication why it's important to reveal the structure, and then we've covered some different ways to show plots based on if you have numeric or categorical data. This show data is sort of, it falls under the same category, but just I think it's kind of an important extra emphasis. This is an example of something known as a dynamite plot. These are kind of, I hate dynamite plots. They're like a real disaster, but you'll see them a lot if you work in medicine or more often in bench science, like lab sciences. So if you work with like biological data or data that's generated from a wet lab, a lot of times you'll see these because they're automatically generated by a lot of software. So it's important to sort of know that this exists. And the problem with these is that they obfuscate information. So if you actually drew the points over this data that I generated, you would see that this bar here is fully based on just 5 data points, which is kind of misleading. So it can look like there's, by just showing the bar, there's no indication that that is based on just 5 data points. And similarly, this one down here is based on a whole lot of data points. And so if you were trying to sort of detect if there was a meaningful difference between these different groups, it can change the picture if you actually give full information about how many data points are representing those summary measures. Okay, so putting this all together, what I want you to do is go back to that plot that you were starting that had those labels. And I want you to plot that Val rank episode 1 by the cat favor Padme among your survey, the young survey respondents. And I want you to do that. I would like for you to do that as a box plot. And I want you to also add that layer of individual points on top of that box plot. So to add those points, you're going to need that geom_jitter function. So go ahead and spend about 4 minutes working on this plot, and then we will do it together. All right, so what is the first thing, what geometric object are we first trying to put on this plot? A box plot, right. So what would I use, what function would I use to do that? Yeah. Yeah, outlier shape equals NA, exactly. So now I'm just gonna run this just to show you what this looks like. And this is what I get here. And so if I wanna add on those actual data points so I can see how many points are representing each of these parts, what would I do for that? GeomJitter, exactly. And so now I see these, and if I want these points to not be quite so dark since there's some overlap, what would I do to maybe make these be a little bit lighter, like transparent? Yeah. So the color function, if I use the color function, that will change the color, but it doesn't actually change the transparency. Does anybody know how to change the transparency? Alpha, yeah, exactly. So I'm going to leave them blue because I think that's pretty, but I'm going to set the alpha, and you can set this to some value between 0 and 1, and it basically sets the percentage of the transparency. So if I set it to 0.5, for example, that'll give like a half transparency. So now they're a little bit lighter, so I can see kind of those points a little better. Great. So by doing this, there's something that I noticed. At the top here, I've got this NA category. And so this would be people who just didn't answer that question at all. And kind of depending on your on what you're doing, you might want to remove those. In my case, I'm going to say we do want to remove them. And so what I'm going to do is, instead of having this data frame as the first argument, I'm going to take that data frame up here and I'm going to pipe it into a filter function. And then I'm going to pipe the output of that into the ggplot function. And so this is going to do the same thing because the first argument of the ggplot function is the data frame. And so this will let me basically filter how I'd like to and then plot it. So if I don't add anything to this filter function and just run it, I'm going to get that exact same plot that I got before. I'm just going to give you all a second to be able to put in this. So we're just taking that young Star-Wars survey data and I'm piping it into the filter function and then piping the output of that into this ggplot. So I've deleted young Star-Wars survey from the first argument and I've deleted the comma so that I can just add in a filtered data set here. Now, if I want to filter so that I don't have any missing values for this categorical Padme favorability variable, what would I do to do that? What logical statement could I use? Does anybody remember a logical statement that checks for missingness? So there's this function called is.na, and this will check, it'll check like whether or not whatever is inside it is missing. And so I can put that cat favor Padme into this is.na, and this will be true if it's missing and false if it's not. And so if I want to only include the ones that are not missing, I can use an exclamation point in front of it, and that will subset to only the rows where there's no missing data for that category. Does that make sense? Yeah. And I think you can actually see, oh, maybe not. Let's see, this doesn't. If you go to the help and cheat sheets under data transformations, you should be able to see this is.na as one of the potential logical operators that you can use. Okay, so if I run that, now I get rid of that top missing column that was kind of a pain before. So there's still some things to update on this particular plot. For example, what we're going to get to next is that the ordering here isn't totally logical. So we've got very unfavorably, very favorably, unfamiliar, somewhat unfavorably, somewhat favorably, and neither favorably or non-favorably. And so this is ordered alphabetically. which is probably not the most sensible way to look at this data since we know that this is a ordered category. And so now we're going to see how to actually order that so that you get something sensible when you're presenting this information. Okay, so we want to make sure we reveal the structure and we show the data. Even if we do both of those things, if the plot is not properly scaled, you'll still be able to see some misleading results. So for example, here is a plot where I've got something on my x-axis and something else on my y-axis. And notice my y-axis here goes from some value up to 160. I can plot this exact same data, but if I really stretch my y-axis up to 5,000, it looks totally different. So the line looks basically flat. When I looked at it here, it looks like there's a strong positive correlation between my x and y variable. And when I look at it like this, it looks like there's basically no correlation between these. So this is just a demonstration of how the way that you scale your axes is really important for the message that comes across. And generally, it's important to kind of keep this to the range of values that you're interested in. So if the true data start at 0, you want your axis to start at 0. If the true data do not start at 0, then you don't want your axis to start at 0. I think this is something that I hear a lot when talking about axis and properly scaling. And this starting at 0 is it's like an adage that people repeat often, but don't always think about exactly what it means. It is the correct thing to start at 0 when the true scale starts at 0, because otherwise you can show misleading results. But if the true scale does not start at 0, it's not correct to rescale it to start at 0. So I think it's important to sort of think about the actual underlying data that you have. So here's an example where perhaps the data really should start at 0. So this, I'm plotting here 2 points here, these point ranges, where one is up here and, at 98 to 100, and one is down here at 94 to 96. And when I plot it like this, it looks like there's potentially a large difference between these 2 points. But if you knew that this actual scale was from 0 to 100, and you showed that full scale, you might not see that same big difference between those points. And so it's important, if the true scale really does start at 0, to start it there, and if not, to not start it there. Okay, so we have revealed our structure, we've shown our data, it's properly scaled. Now the last part, or the second to last part, is making sure it's sensibly arranged. So here's a bar plot where it's potentially not sensibly arranged. It's hard for a viewer to look at a bar plot like this and sort of know what to get from it. And so in general, if you have data that are not, if the data, if the categories are not ordinal, it often makes sense to order them in frequency. That can kind of help draw attention to the viewer to sort of understand what you're trying to have them see. There are different cases though when order is implied. So for example, here I've plotted the Star Wars, how frequently people had seen different Star Wars films. And this ordering is just alphabetical, which is probably not the sensible ordering. But it also maybe wouldn't necessarily make sense to order this by frequency, because we know that these movies are inherently ordered. So a content matter expert might expect these to be in the order that the films came out. And so to do that, you would want to reorder these factors so that it's actually in the order that the films were released, to maybe be able to help the viewer draw some kind of conclusions about kind of the popularity of the different films. So the way that you do this in R is via a package called Forecats, which again is in the Tidyverse package. So you don't have to load it separately. It just loads in when you load that Tidyverse suite of packages. And there's a couple of different ways to re-level the factors. There's 4 that we're going to be using that I'll focus on today, which are sort of the most frequent ones that I see. And so when you want to do this, you can create a new variable that has the re-leveled factors, or if you're only using it for the plot, you could overwrite the previous variable as well and just re-level them. And so there's the factor re-level function, which will re-level the factors based on a character vector of the levels that you would like it to be. There's a factor rev, which will reverse the factor order. There's the factor infreq, which is what I'm using here, which basically will order by the number of observations in each level. So this is the sensible thing to do if you have an unordered factor variable. And then factor in order is going to order by the order in which they first appear in the data set. So sometimes if you are reading in certain data and you know that the order that they appear in the data set is a sensible order, that would be the one that you would want to use. So we only have 3 more minutes, so I'm actually going to pause here and we'll pick up this application exercise next time so that you can actually use that factor relevel, practice using it. So in these next couple minutes, I'm just going to highlight that this is how you would do it, but what I've done here is actually not the sensible ordering for this particular variable. So I'm saying this factor in freq, which is going to order it by the number of observations. But we know this cat_favor Padme variable is actually ordered categorical because it goes from not favorable up to very favorable. And so the actual correct way to order this probably for a figure is going to be to use the factor relevel function, where we pass it a character vector with the right ordering. And so that's what you're going to do when we start class on Monday. Are there any questions about what we've covered so far? Okay, so the rest of Monday is going to be finishing up this data visualization, and then I think we should also be starting a little bit on the linear regression piece. And I do encourage you, if you have the time, to try to fill out that little feedback. It doesn't have to be long, but just so I can make sure that I'm able to incorporate things that are going to be useful for your projects, because I think some of you will not be modeling, but some of you will be. Oh, one other thing I wanted to mention that I will show on Monday, some folks asked for dashboards, and dashboards in R are actually kind of it's a whole own beast. And I know some of you are going to be working on this as part of your project. So I have a short course that I have created on how to do this, and for next time, I'll create a coupon code for that. So anyone that is interested can take that short course for free. And of course, ask me any questions about the code or anything, but we're not going to cover it actually in class because I don't think we exactly have time with all the other things that we're doing. But continue to tell me the things that you are prioritizing, because often if I can't fit it in to the class, I have other resources that I can point people to. So yeah, all right. Thank you.